Um, Good afternoon, everyone present here. My topic or my project is on prediction on grading diabetic retinopathy fundus photos by CNN algorithm. Introduction, we live in an era where, in the AI era, where we already know that deep learning is a subset of artificial intelligence, where we humans train the model by giving training in the sense we create CNN, convoluted neural network, which are like neurons of a brain. We train the model with an image and it classifies and gives us an output that this is either that or this. So here we are developing a multi-class image classification where it is giving us an output either as 0, 1 or 2. So the purpose is the primary outcome measure is to build a model and find out accuracy on training with diabetic fundus images. So methods, we took a total of 106 fundus images, which are comprising of 18, that is normal. We categorized it as DR1, 49 NPDR images, and we categorized it as DR2, and 39 PDR, which is DR3. Then we use the software Google Collaboratories, and the steps involved are as follows, and let me walk you through the steps here. So we initially took the folder and divided them into training, testing, and validation folder. 70% of photos go to training, 20% go to validation, and 10% go to testing. So now we are trying to visualize images. This is a coding just to visualize one image. So here we are able to visualize a PDR photo categorized as DR3. Now we are actually finding out what are the dimensions of each image. Now after seeing one image, we are trying to see the entire folder. In the first cell, we are trying to visualize the first 10 photos belonging to the normal category, that is DR1. Next coding, we are trying to visualize the first 10 photos belonging to the category of NPDR. DR2. In the next cell, we are trying to execute a program where we are visualizing the first 10 images belonging to PDR category, that is DR3. Now we got all the images. We are augmenting the images so that we are training the model and rescaling the images. We are dividing the images into training, validation, and test images. The test images will not undergo any training. It is used directly for testing. So the model doesn't know what the actual test images are. This is the model of our CNN algorithm, and this is the architecture. So here we are showing that we are using two hidden layers and one CNN layer, and the dense layer is giving an output as 0, 1, or 2. This is where we are fitting the model and we are training the machine. So by 20th epoch, we can see our validation accuracy is around 73.68%. Now we are assessing and plotting how our model has performed. We can see both accuracy and loss. The graphs are very near, suggesting the model has been trained well. And now we are fitting the model, trying to see how it predicts on the validation images. So these are the coding which we are turning. The machine predicts them in a form of an array. And now these arrays are converted into class indices, that is either 0, 1, or 2. By end, we are predicting the validation, confusion matrix, and classification report, which I'll show in the results section. And this is the ROC curve for each category. And now the main part is coding for an unknown image. So here we can see a random image has been taken from a directory belonging to test, that is the DR3. These test images are not trained by the model earlier. Now it is predicting an image belonging to PDR as PDR properly with a confidence interval of 90.03%. So results, this model achieved a training accuracy of 79.45% and validation accuracy of 78.95%, and a good F1 score of 0.67 was calculated for accurately grading the diabetic fundus images. Area under curve in the ROC curve showed values of 50, 54, and 52% for DR1, DR2, and DR3 respectively. Conclusion is, these steps and coding for this model is replicable even for large ophthalmic image data sets, and we can obtain a good accuracy, and this accuracy can be increased by image augmentation methods by adding more layers to this and adjusting the number of epochs and optimizers. Thank you. These are my references.
So what you have done is generated another AI convoluted neural network model to diagnose or for the grading of images of diabetic retinopathy. What is this advantage over so many which are already there available?
The advantage is that, ma'am, this is a simple model which you have constructed using just two convoluted layers and two hidden layers. So the other models which we get are usually built by a engineering department or built backed by a department which has a proper engineering assistance. So this was just, we wanted to build a model where we didn't want to depend on anybody and build a template. So this can act as a simple template. Using this as a skeleton, instead of the diabetic retinopathy images, if we copy the path of fundus images, like instead of 0, 1 or 2, we can code it for giving the output as 0 or 1, where it can say 0 means it is probably normal, 1 it is probably glaucomatous. And we have already tried the model on fundus images.
Who developed it?
Me and our HOD sir, we sat and...
No engineer involved at all?
No engineering.
So how did you have the background knowledge to do this?
Background knowledge, we spent times watching, there are so many websites where Geek for Geeks is a very popular website. And there are many youngsters who are training YouTube videos where they're teaching how to classify. Like we started by taking with, the initial video was an animal, whether they're telling whether this is a dog or a cat or a panda. So starting from that, all the codings are actually very complex, ma'am, if you see. We wanted to have a simple coding which you can act as a template. You remove the glaucomatous fundus, put retinopathy, it will classify it. You remove or put keratoconus images or anything, we'll get an accuracy, sensitivity.
Very good.
Did you compare your sensitivity and specificity with any other tool?
Yeah, we compared with the other two, ma'am.
So how did it stand out?
Ours was 78% sensitivity what we got. The other models which had 91, 92 percentages were there. The sensitivity of the same model can be increased by adding image augmentation, which can be next level, and adjusting batch normalization is the term which is used, where we usually flip, horizontal flipping, adjusting the image height, width, shape can be done, and this can further enhance, ma'am. So we wanted to show a basic architecture and a skeleton.
Yeah. So very good study. I think we are short of time, so we can have discussion at the end.
I'm from JSS Medical College,
Thank you.
final year PG.
Very
Thank you.
Thank you very much. May I ask Dr.